Hi everyone, welcome to the Organic Chemistry Revision Series powered by NEETshala. In this lecture, we will be discussing the chapter Environmental Chemistry from the point of view of NCERT and also for the examination of NEET. So let's get started with the chapter Environmental Chemistry. Environmental studies, as you know, deals with the social, economical, biological, physical and chemical interrelations with our surroundings. Now, in this unit, we will be focusing mainly on the chemical aspects in the topic that is environmental chemistry. Environmental chemistry deals with the study of the origin, transport, reactions, effects, and fates of the chemical species in the environment. So let's explore further with environmental chemistry. In this chapter, the main focus is on environmental pollution, the types of pollution, and finally, we'll be dealing with green chemistry. So let's get started with the first topic, that is environmental pollution. Environmental pollution is the effect of undesirable changes in our surroundings that can have harmful effects on plants, animals, and human beings. Now, what is a pollutant? A pollutant is any substance which causes pollution. Now, these pollutants can either be solid or liquid, or they can be gas also, if they are present in greater concentration than in natural abundance. And these can be produced either due to human activities or it can be produced due to natural happenings, like in the case of forest fire and things like that. Do you know an average human being requires nearly 12 to 15 times more air than food? So even small amounts of pollutants in the air becomes significant as compared to the similar levels which is present in the food. So, air pollution is more critical, right? The pollutions, now we can divide it into two on the basis of the microbial action. The first one is known as degradable pollutants, and the other is known as non biodegradable pollutants. If we take the case of dichloro-diphenyl trichloroethane, which is DDT, that is an example for non biodegradable pollutant. Why is it not so? Because it is unable to be degraded by the bacteria and other microbes. Now, these in the process of environmental pollution, the pollutants, they originate from a particular source and they are transported by different means like air, or even it can be transported by water, and it is dumped into the soil by the human beings. So these are the different ways in which pollution are caused. So let's move forward. Let's move on to the first type of pollution, which is known as atmospheric pollution. The atmosphere that surrounds the earth, that is not of the same thickness at all heights. It is basically made up of some concentric layers of air, or regions which we can say of different density. So if we take the lowest layer, that is known as the troposphere, and troposphere will extend only greater than 10 kilometer from the sea level. So if this is the sea level, the distance between the troposphere and the sea level is 10 kilometer. This is 10 kilometer. And if we move 10 to 15 kilometer away from the troposphere, then it is known as stratosphere. So the next layer is the stratosphere. Now these are the two important layers where pollution is happening. So let us see what is happening in the troposphere and also in the stratosphere. So first of all, let's understand the features of troposphere and stratosphere. We have studied the height or the altitude at which both of these layers are present. Troposphere extends up to a height of 10 km from the sea level, and above the troposphere between 10 to 50 km lies the stratosphere. Now, troposphere, as you can see, is a turbulent, it is a dusty zone, and it consists of air, water vapor and clouds. So the winds and the movement of clouds happens in the troposphere, whereas stratosphere contains dinitrogen, dioxygen, ozone and very little water vapor. So ozone, the good ozone is present in the stratosphere. Now let us see about tropospheric pollution first. Tropospheric pollution occurs due to the presence of undesirable solid or gaseous particles in the air. So let us classify these gaseous particles into oxides of sulfur, oxides of nitrogen, oxides of carbon, hydrogen sulfide, hydrocarbon, ozone and other oxidants. And particulate pollutants includes dust, mist, fumes, smoke, smog and so on. So let us look at each of these in detail. So the first one is the gaseous air pollutants, wherein we are going to discuss about many oxides. The first one is oxides of sulfur. Now oxides of sulfur are produced when sulfur containing fossil fuel is burnt. The most common species is going to be sulfur dioxide, which is poisonous to both animals as well as plants. So even a very low concentration of the sulfur dioxide can cause us respiratory diseases. Now examples for these respiratory diseases includes asthma, bronchitis, emphysema, etc. Sulfur dioxide can also cause us irritation to the eyes. It can also cause us tears and redness in the eyes. Also in plants also it is affected, so it is leading to the stiffness of flower buds, which eventually leads to the fall off of the flower from the plants. Now SO2 can convert into another poisonous gas, that is SO3, but it is a slow process. So it is catalyzed by ozone. The ozone which is present in the higher levels of troposphere and also in the stratosphere can help in the conversion of SO2 into SO3. And also if it is reacting with the water or even in the presence of hydrogen peroxide, it can give H2SO4, and that is released back into the earth in the form of acid rain. Now let us move on to the oxides of nitrogen. Now the main oxides of nitrogen includes NO2, NO3 and so on. So let us take NO2 because this is the major pollutant. Now dinitrogen and dioxygen are present in the air, but these are not much reactive. But under certain conditions, like when there is a lightning, or even in the automobiles when they are combusted, what is happening is that they can react. So at high temperature, that is reacting to form NO. Now this NO is reacting initially instantly with oxygen to give NO2. Now the rate of production of NO2 is faster when nitric oxide, that is NO, reacts with ozone. So this particular oxide is produced in the presence of ozone, that is in the troposphere. So tropospheric ozone is not so good because it helps in the production of many poisonous and pollutant substances, right? Polluting substances. So that is why the tropospheric ozone is also known as bad ozone. So let us now see some of the harmful impacts of this NO2. If you are seeing the traffics of Delhi or any other metropolitan cities, we can see that there is an irritant red haze, right? So this red haze is due to the oxides of nitrogen. And also the higher concentration of NO2 can damage the leaves of the plants, and it can also retard the rate of photosynthesis. Now, nitrogen dioxide is again a lung irritant, and it can also lead to acute respiratory diseases in children. Again, it is harmful to the living tissues, and also it is harmful to the various textile fibers and also to certain metals as well. So now let us look at the third important pollutant, that is hydrocarbons. Now hydrocarbons are produced by the incomplete combustion of fuel. It is produced by the incomplete combustion of fuel, and as we have studied in the chapter hydrocarbons, majority of them are carcinogenic. That means they cause us cancer. So that is toxic to humans because it causes cancer. And what effect are they having on plants? They are having a majority of effect in the plants. First, includes the breakdown of the tissues, second is the shedding of the leaves, third is the shedding of the flowers, and the fourth is the shedding of the twigs. So it is having harmful effects both in plants as well as in animals. Let us now move forward to the next oxide, that is oxides of carbon. Carbon mainly has two oxides. The first one is known as carbon monoxide and the second one is known as carbon dioxide. So we can see carbon is forming two oxides, one is carbon dioxide and the other one is carbon monoxide. So which law of chemical combination is obeyed over here? We can see that the mass of the carbon is constant, so the mass of oxygen is following a simple whole number ratio, so the law of multiple proportion is followed over here, right? We can just relate it with some of the basics concepts also. So let us see the oxides of carbon. The first one is carbon monoxide. Now carbon monoxide, as you have studied in biology, it is a very serious air pollutant. Now why is it a serious air pollutant? Because it is blocking the hemoglobin, or it is reducing the oxygen carrying capacity of the hemoglobin. What happens is that the carbon monoxide will react with the hemoglobin. It will bind to the hemoglobin and it will form carboxyhemoglobin. Now, hemoglobin likes this carbon monoxide very much, that it does not leave it very easily. It gets strongly bind to the hemoglobin, and as a result of which no more oxygen can bind to this RBC, or we can say the hemoglobin molecule, right? So this can have serious impact on the health of the individuals, like it can lead to headache, it can lead to weak eyesight, it can also lead to nervousness, cardiovascular disorders, and that is the reason why people are advised not to smoke. And even in the pregnant woman, it is very important that they should not use smoke or cigarettes. The reason being, the increased carbon monoxide level in the blood can result in premature birth, spontaneous abortions, and also in deformed babies. So this is the harmful impact of carbon monoxide. Now let us talk about carbon dioxide. Carbon dioxide is released into the air by respiration, burning of fossil fuels for energy, and by the decomposition of limestone during the manufacture of cement, that is CaCO3 on decomposition will give us CaO plus CO2. This is the reaction. Now, it is also emitted during the volcanic eruptions. Now, this carbon dioxide gas is confined only to one layer, that is troposphere, and its percentage is just 0.03 percentage. Now, what happens is that the excess amount of carbon dioxide which is present in the atmosphere is fixed by the green plants, or it is removed by the green plants, and that is going to maintain an appropriate level of carbon dioxide in the atmosphere. But what happens is that green plants require carbon dioxide for photosynthesis, and in turn they will emit the oxygen, and as a result they are going to create a balance between carbon dioxide and oxygen. But if there is increased fossil fuel burning and if there is increased deforestation, what is going to happen in the presence of these things? The carbon dioxide level in the atmosphere is going to increase, and that is going to result in global warming. So let us look further. Let us see what is global warming and greenhouse effect. About 75% of the solar energy which is reaching the earth is absorbed by the earth's surface. And this is very important because this trapped sunlight produces heat, and that heat is required for the earth's surface, for heating up the earth's surface to increase the temperature of the earth's surface. Rest of the heat radiates back into the atmosphere. Some of the heat is trapped by certain gases such as carbon dioxide. We can see over here carbon dioxide, methane, ozone, chlorofluorocarbon compounds, and water vapor. So these are known as greenhouse gases. So which are the greenhouse gases? It is carbon monoxide, methane, ozone, chlorofluorocarbon, and water vapor. So they will also help in the heating of the atmosphere, and this can ultimately result in global warming. Now, let us study about natural greenhouse effect. Natural greenhouse effect means our earth is like a greenhouse. You might have seen the greenhouse, right? It's a glass jar where the plants are grown. So once the sunlight or once the radiations enter inside, it is not going outside, that is, it is trapped inside the greenhouse. So the same thing is happening in the earth also. Due to the presence of these greenhouse gases, the temperature of the earth remains nearly constant. But what happens is that due to human activities, what has happened is that this ability has led to a disaster. This is leading to the global warming because the carbon dioxide has increased, so it can trap more and more sunlight. As a result, the temperature of the earth is increasing slowly. The annual temperature or the mean temperature of the earth is increasing slowly, and this has resulted in a phenomena which is known as global warming. Now, this global warming will also result in certain diseases, that is, it will help in the proliferation of certain disease causing microbes, and as a result of which it can result in diseases like dengue, malaria, yellow fever, sleeping sickness, and so on. Now, let us move forward. Let us talk about acid rain. Now, you already know that our water, that is rainwater, it has a pH of 5.6. Now what is the reason for that? It is mainly due to the H plus ions which is produced, right? This H plus ions which is produced by the combination of water and carbon dioxide. So when water and carbon dioxide is reacting, it will result in the formation of H2CO3 and this H2CO3 will dissociate to form H plus and HCO3 minus. So this H plus is responsible for the acidic nature of the rainwater. Now, when the pH of the rainwater is dropping below 5.6, then it is called as acid rain. Now, acid rain is basically the ways in which the acid from the atmosphere is deposited on the Earth's surface. Oxides of nitrogen and sulfur, oxides of nitrogen as well as sulfur, are acidic in nature, and hence they can be blown by wind along with the solid particles in the atmosphere, and finally they can settle down either on the ground, right? It can settle on the ground of dry deposition, that is dry oxides of sulfur and nitrogen can be present, or it can be present in the water, fog or snow. It can be precipitated down in the form of water, fog or snow, then it is known as wet deposition. So this point is important: what is dry deposition and what is wet deposition. Dry deposition means the oxides of nitrogen and sulfur are carried away by winds and it is falling on a certain surface. And what is wet deposition? Wet deposition means the oxides of nitrogen and sulfur, they are dissolved in fog or mist or rainwater, and it is reaching the surface of Earth. This is known as wet deposition. Now, acid rain is a byproduct of variety of human activities that emit the oxides of sulfur and nitrogen in the atmosphere. As mentioned earlier, burning of fossil fuels containing nitrogen and sulfur, such as coal and oil in power stations and furnaces, or even petrol and diesel in motor engines, these are responsible for the production of sulfur dioxide and also nitrogen oxides. Now these SO2 and NO2, after oxidation and reaction with water, they are going to form major acids such as H2SO4, and we have HNO3. Similarly, we have the ammonium salts. The ammonium salts are also formed and can be seen in the atmospheric haze, that is in the aerosol of fine particles. So the aerosol particles of oxides or ammonium salts in the raindrop can also result in wet deposition. SO2 is also absorbed directly on both solid and liquid surfaces and is thus deposited as dry deposition. So ammonium salts is basically seen as wet deposition, and sulfur dioxide is basically seen as dry deposition. Now, what are the harmful impacts of acid rain? Acid rain is harmful for agriculture, trees and plants, as it dissolves and washes away the nutrients which is needed for the growth. It causes respiratory ailments in human beings and animals. When acid rain falls and flows as groundwater to reach rivers, lakes, etc., it is going to affect the plant and animal life in the aquatic ecosystem. It is also going to corrode water pipes, and that can result in the leaching of heavy metals such as iron, lead, copper, etc. into the drinking water. And it can also damage the prestigious monuments like the Taj Mahal, right? So these are the harmful impacts of acid rain. So now we have a case study of Taj Mahal and acid rain. The air around the city of Agra, where Taj Mahal is located, contains fairly high levels of nitrogen as well as sulfur oxide. Now this is basically due to the large number of industries and power plants around the area. Use of poor quality of coal, kerosene and firewood as fuel for domestic purposes add up to this problem. So as a result of this, what happens is that the calcium carbonate, that is marble, which is the major component of Taj Mahal, is going to react with H2SO4 to form CaSO4 plus H2O and CO2. This is causing damage to this wonderful monument that has attracted people from all around the world. As a result of which, the monument is slowly disfigured and the marble is getting discolored and it is losing its luster or the shyness. Government of India has announced an action plan as early as 1995 to prevent the disfiguring of this historical monument. Madura refinery has already taken suitable measures to check the emission of toxic gases. Now we have a plan which is known as Taj Trapezium, which is cleaning the air in the areas around the Taj Mahal. That is basically in the towns of Agra, Firozabad, Mathura, and Bharatpur. Under this plan, more than 2,000 polluting industries lying outside the trapezium, that is the Taj trapezium, would switch on to the use of natural gas, or it can use liquefied petroleum gas instead of coal or oil. So coal and oil are prohibited now, and they can use either natural gas or they can use liquefied petroleum gas. Now, a new natural gas pipeline would bring more than 500,000 cubic meters of natural gas a day to this area. People living in the city will also be encouraged to use liquefied petroleum gas in the place of coal, kerosene, or firewood. Vehicles playing on highways in the vicinity of Taj Mahal is also encouraged to use low sulfur content diesel, because we have already studied that sulfur on oxidation forms SO2 and that is a serious pollutant. With this, we have completed the tropospheric pollution. Now let us see the stratospheric pollution. First one is the formation and breakdown of ozone. As we know, the upper stratosphere, it consists of considerable amount of ozone, and it helps in protecting us from the harmful UV radiations which is coming from the sun. And these radiations are causing skin cancer, and skin cancer has a technical name, that is melanoma. Therefore, we have to be protected from the harmful effects of this ozone, right, of the harmful radiations. So we have some ozone layer in the stratosphere which is a product of UV radiations acting on dioxygen molecules. So in the presence of UV radiation, it is forming nascent oxygen. Now this nascent oxygen is reacting with O2 to form O3. This O3 is thermodynamically unstable, and thus it decomposes to molecular oxygen. Hence, we can say there is a dynamic equilibrium that is existing between the production as well as the decomposition of oxygen and ozone. In the recent years, there have been reports of the depletion of this ozone because of the presence of certain chemicals in the stratosphere. Now, the main chemicals are the chlorofluorocarbon, also known as freons, and these are non-reactive, non-flammable, non-toxic organic molecules, and therefore are used in refrigerators and air conditioners. Now, what is happening is that the chlorofluorocarbon, that is CF2Cl2, that can result in a homolytic cleavage leading to Cl free radical and CF2Cl free radical. This Cl free radical is going to react with the ozone, and as a result of which it is going to split the ozone to form O2 and ClO free radical. Now this ClO free radical is going to react with another molecule of oxygen, and as a result of which it is going to degrade. It is going to react with another molecule of nascent oxygen, and as a result of which it is going to again generate Cl free radical and O2. Now what is happening? This Cl free radical again is going to destruct the ozone. So the amount of oxygen is decreased. The amount of ozone is decreased, the amount of ozone is decreased, and the amount of oxygen, that is dioxygen and oxygen, nascent oxygen, that is also increased. These two are increased. As a result, what has happened? The thickness of the ozone layer gradually gets decreased, and this decrease in the thickness of the ozone layer can result in ozone layer depletion. So let us learn about ozone hole. In 1980s, the atmospheric scientists working in Antarctica reported about the depletion of ozone layer, which is commonly known as ozone hole, over the South Pole. It was found that a unique set of conditions was responsible for the ozone hole. In the summer season, nitrogen dioxide and methane is going to react with the chlorine monoxide, that is ClO, and chlorine atoms, forming chlorine sinks, preventing much of the ozone layer depletion. Whereas in the case of winter, what is happening? There is a special type of clouds which is known as polar stratospheric clouds that is formed over Antarctica. And these polar stratospheric clouds provide the surface on which the chloride nitrate gets hydrolyzed to form hypochlorous acid. So these are the set of reactions that is happening. First, we have ClO free radical in the presence of NO2 will form ClONO2. That is this particular reaction. Chlorine nitrate to form hypochlorous acid. And now what is going to happen? The chlorine free radical can react with the CH4. It can form CH4, CH3 free radical and HCl. ClONO2 can also react with water and it can form HOCl and HNO3. ClONO2 can react with HCl to form Cl2 and HNO3. So when sunlight returns to Antarctica in the spring, what happens is that the sun's warmth is going to break down this ClONO2, and it is going to form HOCl and Cl2. Now these are photolyzed again. As per these two reactions, we have HOCl converted to OH free radical and Cl free radical, and Cl2 is also giving rise to 2Cl free radical. So both the Cl free radical, they are going to again initiate the chain reaction for ozone depletion. So what is happening? Once again, we'll just have a quick recap. In the summer season, what is happening? In the summer season, nitrogen dioxide and methane is going to react with the chlorine monoxide, and as a result of which they are going to form the chlorine sink, and this chlorine sink is responsible for majority of the ozone layer depletion. Now during the winter, what happens is that there is a special type of clouds which is known as polar stratospheric clouds, and these polar stratospheric clouds are responsible for the reaction of chloride nitrate, that is going to react with water to form HOCl, and it can also react with HCl to form Cl2. Both of these, during the sunlight, in the presence of sunlight, they will get converted into chlorine free radical, and this chlorine free radical is again going to result in the depletion of ozone hole. Now let us study the effects of depletion of ozone layer. With the depletion of the ozone layer, more UV radiations filters into the troposphere. UV radiations leads to the aging of skin, cataract, sunburn, skin cancer, killing of many phytoplanktons, and damage to the fish productivity, etc. It has also been reported that the plant proteins get easily affected by UV radiations, which can lead to harmful mutation of the cells, and it can result in the evaporation of surface water through the stomata of the leaves and decreases the moisture content of the soil. Increase in the UV radiation can also damage the plants and fibers, and as a result of which they get faded faster. Let us now move on to water pollution. But before we move on to the water pollution, we have to talk about particulate pollutants as well. So let us talk about particulate pollutants and also about the photochemical smoke, about the smog in general. So let's start with the particulate pollutants first. Now, what are particulate pollutants? These are basically minute solid particles or liquid droplets in the air. Now, these are present in the vehicle emissions, they are present in the smoke particles from fires, or even the dust particles and ash from the industries. Particulates in the atmosphere, they can be of two types. Either they can be viable, that means living, or they can be non-viable, which means non-living. Now, viable includes bacteria, fungi, molds, algae, and these are some of the examples of viable pollutants, and we have some non-viable pollutants as well. Now these non-viable pollutants are of the following type. We have smoke particles, which is consisting of solid or mixture of solid and liquid particles, which is formed during the combustion of organic matter. Second is dust, which is consisting of fine solid particles over 1 micrometer in length, or we can say 1 micrometer in diameter. Now the third one is mist, which is formed by the particles of spray of liquids and condensation of vapors in the air. Now the fourth one is the fumes, which are obtained by condensation of air of vapors during sublimation or distillation, boiling, and other chemical reactions. So we can say generally organic solvents, metals and metallic oxides from the fume particles, they are going to be falling under this particular category. Now the effect of a particulate pollutant are largely dependent on the particle size. Airborne particles such as dust, fumes, mist, etc., these are dangerous for the human health. Now, if we have a particulate pollutant which is bigger than 5 microns, that is likely to lodge into the nasal passage, and as a result of which they are going to disrupt the pathway of air, and if it is of the length of 10 micron, then it is going to enter into the lungs easily. Now, lead is used as a major air pollutant is emitted by the vehicles. Now, leaded petrol is the primary source of airborne lead emission in Indian cities. So, to overcome that, nowadays we are using unleaded petrol. So, that is an important point. Nowadays we are using unleaded petrol, and as a result of which we can reduce the lead pollution. Now, what is the harmful effect of lead? Lead will interferes with the development and maturation of RBC. So, this particular point is very important from NEET point of view. Lead interferes with the development and maturation of RBC. So let us now move forward to smog. This is the most important topic from this chapter. Most important topic from this chapter is smog. Now, smog is a combination of smoke and fog, and this is the most common example of air pollution that occurs in many cities throughout the world. There are two types of smog. The first one is known as smog. So remember C for C. So classical smog occurs in humid climate, cold and humid climate, and it is a mixture of smog, fog, and sulfur dioxide. So we can say it is a reducing mixture, and hence it is also a reducing smog. So these characters of reducing as well as oxidizing smog is very important. Classical smog occurs in cool, humid climate, and it is a mixture of smoke, fog, and sulfur dioxide, and it is a reducing mixture, and hence it is known as a reducing smog. Now, what about photochemical smog? Photochemical smog occurs in warm, dry, and sunny climate. The main components of the photochemical smog result from the action of sunlight on unsaturated hydrocarbon and nitrogen oxides, which is produced by the automobiles and factories. Now, this photochemical smog has high concentration of oxidizing agents, and as a result of which it is known as the oxidizing smog. Let us now move to the formation of a photochemical smog. More than this particular part is the important one. So let us now just go through the formation. When fossil fuels are burned, a variety of pollutants are emitted into the Earth's troposphere. Two of these pollutants that are emitted are hydrocarbons, that is as a result of unburned fuels, and another is the nitric oxide, that is NO. When these pollutants build up to sufficiently high levels, a chain reaction is occurring. And as a result of this chain reaction, the NO is converted to NO2. This NO2 in turn will absorb energy from the sunlight, and as a result of which it is going to react to give NO and nascent oxygen, that is free oxygen atom. Now these free oxygen atoms are very dangerous because they are very reactive, and they combine with oxygen to form ozone. The ozone that is formed, it is going to react with the nitrogen oxide, and it is going to form NO2, and this NO2 is a brown gas that is sufficiently high levels can contribute to the haze, which we have talked before. Now this ozone can also react with methane or acrolein to form PAN and formaldehyde. Even these are harmful substances, harmful pollutants. Now, what are the effects of this photochemical smog? Common components of the photochemical smog are ozone, nitric oxide, acrolein, formaldehyde, and peroxyacetyl nitrate. Photochemical smoke can cause serious health problems. Both ozone and PAN can act as powerful eye irritants, and ozone and nitric oxide irritate the nose and throat, and their high concentration can cause us headache, chest pain, dryness of the throat, cough, and difficulty in breathing. So both of these can result in cracking of rubber, and also can cause extensive damage to the plant life, and it can also cause us the corrosion of metals, corrosion of stones, building materials, rubber, and painted surfaces. Now how can we control this? The methods are as follows. The first one is, if we control the primary precursors of photochemical smoke such as NO2 and hydrocarbons, and then the secondary precursors such as ozone and PAN, the photochemical smoke will be automatically reduced. So by using catalytic converters in automobiles, it can convert nitrogen oxide, and hydrocarbons can be reduced, because nitrogen oxide get converted to nitrogen and dioxygen, which are comparatively less polluting, and hydrocarbons are completely combusted to form CO2 and H2O by the use of catalytic converters. So that is one method of reducing this particular type of photochemical smoke. Now another way is by the use of certain plants such as pinus, juniperus, quercus, pyrus, and vitis, which can metabolize nitrogen oxide, and therefore the plantation could help in reducing of the photochemical smoke. Let us now move further to the next part, that is water pollution. Now, as we know, water is very essential for life, and without water, there would be no life. We usually take water as granted for its purity, but it consists of very few amounts of pollutants as well. And this pollutants originates as a result of human activities through different paths. Pollution reaches the surface or groundwater. Easily identified source or place of pollution is called as a point source. Example, the municipal or industrial charge discharge pipes, where pollutants either enter into the water source. Now we have non-point sources as well. Non-point sources means which cannot be easily identified. For example, we have agricultural runoff from farms, animals, and croplands, acid rain, stormwater drainage, etc. These are some of the non-point sources of water pollution. Let us now see what are the causes of water pollution. The major cause is the pathogens. Now, what are pathogens? Pathogens are basically the bacteria and other organisms which is causing diseases in humans. Example, we have Escherichia coli and Streptococcus faecalis, which is present in the human excreta and it can cause gastrointestinal diseases. So this is important. Let us move on to the next topic, that is organic waste. The other major water pollutant is the organic matter such as leaves, grass, trash, etc. They pollute the water as a consequence of runoff. Now, extensive phytoplankton growth within the water, even that can be a cause of water pollution. The wastes are usually biodegradable. Now let us see the effect of population of bacteria on water. Large population of bacteria decomposes the organic matter which is present in the water. As a result of which they are going to consume oxygen which is dissolved in the water, and as a result of which the amount of dissolved oxygen is going to be declined. DO will decline, and as a result of which what is happening, the aquatic life does not have enough oxygen to survive, and when they have no oxygen to survive they die off. So the growth of fish gets inhibited. Oxygen reaches water through atmosphere or from the process of photosynthesis carried out by many aquatic green plants during daylight. During night, what is happening is that the process of photosynthesis will stop, but the plants continue to respire. And as a result of which there is a reduction of dissolved oxygen. The dissolved oxygen is also used by the microorganisms to oxidize organic matter. If too much of this organic matter is added to the water, all the available oxygen is used up. This causes oxygen dependent aquatic life to die, as a result of which the anaerobic bacteria begin to break down the organic waste and it will produce chemicals that have a foul smell, and these are harmful to the human health. Now the aerobic bacteria, that is helpful for us because it is helping in degradation of these organic waste, and they will help or keep the water depleted in dissolved oxygen. Now we have a term which is known as biochemical oxygen demand. What is biochemical oxygen demand? It is the amount of oxygen which is required by the bacteria to break down the organic matter which is present in certain volume of a sample of water. Now the amount of BOD in water is a measure of how much organic material is present in that particular water. If the BOD is greater, then we can say that it is more polluted. So BOD is directly proportional to polluting potential. That means if BOD is more, then pollution is also more because pollution potential is also more. And BOD is inversely proportional to dissolved oxygen. That means if dissolved oxygen is more, BOD will be less, and if BOD is more, then dissolved oxygen will be less. So this is the two important relations. Now let us move on to the chemical pollutants. Now, as we know, water is an excellent solvent, so there will be many chemical pollutants as well. Let us see some of the chemical pollutants. These are the standard values, maximum prescribed concentration of some metals in the drinking water. Iron, it is 0.2. Manganese, it is going to be 0.05, very less. Then cadmium, as you can see, it is 0.00005, and zinc is 5.0, copper is 3.0, and aluminium is 0.2. So aluminium and iron has the same amount, and zinc up to 5 is possible, but cadmium should be the least, that is 0.005. Let us now see the major water pollutants. We have microorganisms, and it is produced from the domestic sewage. Organic waste, which is produced from domestic, animal excreta and waste, decaying animals and plants discharged from food processing factories. Plant nutrients, which includes chemical fertilizers, toxic heavy metals, which includes industries and chemical factories, sediments, which is caused by the erosion of soil by agriculture and stripe mining, pesticides, which is the chemicals used for killing insects, fungi and weeds, radioactive substances, which is caused by the mining of uranium containing minerals, so this is important, and last one is heat, which is released by the water for cooling in thermal industries. Now let us come back to the topic of chemical pollutants. We have a topic which is known as eutrophication. Now what is eutrophication? Eutrophication is the aging of lake. And why is eutrophication caused? It can be either due to natural processes or it can be due to human processes. Whenever there is increased fertilizers, whenever there is a runoff of increased fertilizers, what is happening is that the phosphates and sulfates which is present in these fertilizers, they will help in the growth of algae, and ultimately the age of the lake will increase, as a result of which the clarity of the lake is lost, and this process is called as eutrophication. It can be of two types. One is known as natural eutrophication, if it is happening naturally, and if humans are helping in it, then it is known as cultured eutrophication. Now, some of the major pollutants of water, chemical pollutants of water includes PCB, it is very important, polychlorinated biphenyls, which is an industrial chemical which is used as a cleansing solvent, detergents and fertilizers. They are a major constituent of water pollution. Also, we have sodium and calcium chloride. Even these are water soluble chemical pollutants, so this is also important. And these metals can have so many negative impacts, such as it can damage the kidneys, central nervous system, liver, etc. Let us now move forward to the international standards of drinking water. Fluoride. For drinking purposes, water should be tested for fluoride ion concentration. This is very important. Deficiency can result in tooth decay. Soluble fluoride often added to the drinking water to bring its concentration up to 1 ppm. The F- ion made on the enamel of the teeth is much harder by converting into hydroxyapatite. The enamel on the surface of teeth into a much harder fluorapatite. However, F- ion concentration above 2 ppm can causes brown mottling of teeth. So this is important. If there is enough fluorine, that is 1 ppm, then it can causes the hardening of the enamel. And if its concentration is increasing to 2 ppm, then it can result in brown mottling of the teeth. At the same time, if we have excess fluoride of over 10 ppm, then it can causes harmful effects to the bones as well as to the teeth, and this is reported in certain parts of Rajasthan. Let us now see about lead poisoning. Drinking water gets contaminated with lead when lead pipes are used for the transportation of water. So the amount of lead, the prescribed amount of lead is 50 ppb. This is important. And if it is exceeding this 50 ppb, what is happening? It can damage the kidney, it can damage liver, and also to the reproductive system. Now let us see the sulfate. Excessive sulfate, that is greater than 500 ppm in drinking water, can cause us laxative effect. Otherwise, it is harmless. Moving on to nitrite. Nitrate has a limit of 50 ppm. Excess of nitrate can cause us diseases such as methemoglobinemia, also known as blue baby syndrome, and this is also important. Now, other metals, maximum concentration of metals, which we have already discussed over here, this one, so this is also important. So let us now move on to the next, that is the soil pollution. Now, India is an agriculture based economy, and green revolution has resulted in large amount of soil pollution as well. Although green evolution has increased in the yield of the plants, it has also led to a large amount of soil pollution because we have excess of pesticides, weedicides and fungicides, which is contributing to this soil pollution. Prior to the World War II, many naturally occurring chemicals such as nicotine, by planting tobacco plants in the crop field, were used as pest controlling substances as the major crops. During World War II, what has happened? DDT was found out to be the major use for the control of malaria and also other disease causing microbes. Therefore, after the war, DDT was put in the agriculture to control the damage caused by the insects, rodents, weeds, and various crop diseases. However, due to adverse effect, it has been banned in India. And pesticides are basically synthetic toxic chemicals with ecological repercussions. The repeated use of the same or similar pesticides can give rise to pests that are resistant to those pesticides and can make these pesticides ineffective. Therefore, an insect resistant to DDT increased. Other organic toxins such as aldrin, dieldrin are introduced into the market by the pesticide industry. So now we can use aldrin and dieldrin. These are some organic toxins which are used in the pesticide industry. Most of the organic toxins are water insoluble. This is important, water insoluble, and they are non biodegradable as well. The high persistent toxins are therefore transferred from the lower toxic level to the higher toxic level in the food chain, and this is known as biological magnification. This is known as biological magnification. At the molecular level, the toxicity is very less, but as we move to the higher trophic level, what is happening is that the toxicity increases. This is known as biological magnification, also known as biomagnification. Let us now talk about some important herbicides. The most important one is NaClO3, which is known as sodium chlorate. Similarly, we have sodium arsenite. These are some of the most commonly used herbicides. Now, what are herbicides? Herbicides are those which are used to kill the herbs which is living, or the weeds that is living in the fields. The unwanted plants, that is known as the weeds. Now, what happens is that most of these herbicides are toxic to the mammals and are not as persistent as organochlorides. So these chemicals decompose in a few months. Like the organochlorides, these two becomes concentrated in the food web. Some herbicides can cause us birth defects. Like we have the endosulfan, which can cause us birth defects. Studies shows that the cornfields sprayed with herbicides are more prone to insect attack and plant disease than fields that are weeded manually. So if we have weeds in the plant, that means the insect attack is less. But if we have no weeds, that is if we are adding herbicides, what is happening? The insects and other pests are acting. Though no more weeds are there, but now the insects and the pests, they are going to depend on the crop field alone, and as a result of which they are going to damage the crop field. So pesticides and herbicides, they are just going to represent a very small fraction of the widespread chemical pollution. A large number of other components that are used regularly in chemical and industrial processes for manufacturing activities are finally released into the atmosphere or into the water. Now let us move on to the industrial waste. Now when we talk about industrial waste, we can broadly classify them into two categories. The first one is known as non-biodegradable waste. Non-biodegradable waste are generated by thermal power plants which produce fly ash. Integrated iron and steel plants which produces blast furnace, slag and steel melting slag. Industries manufacturing aluminium, zinc and copper, they are going to produce mud and tailings. Fertilizing industries can produce as gypsum. Hazardous waste such as inflammables, composite explosives or highly reactive substances, these are produced by the industry, leading with metals, chemicals, drugs, pharmaceuticals, dyes, pesticides, rubber goods, etc. So these substances are not at all good, right? So if it is done by an improper manner, if it is disposed in an improper manner, what has happened is that it can result in pollution, and this is known as pollution by industries, also known as industrial waste or industrial pollution. So they have to be incinerated. The method in which these wastes can be removed is incinerated, whereas small quantities of garbage, they can be either deposited in proper bins, but for solid waste, if not managed effectively, it affects the components of the environment. This is the important point. Now, waste recycling is what we are going to discuss next. Fuel that is obtained from plastic waste that has high octane rating. If it has high octane rating, what is going to happen? It contains no lead. That is the meaning. If octane, now these are available in India. Our cities and towns faced endless hours of power cut. We can also see piles of rotting garbage. There is a good news that we can get rid of both these problems simultaneously. Take produce electricity from garbage. A pilot plant has been set up where removing plastic, glass, paper, etc. The garbage, it is used for producing methane, commonly known as biogas. beautiful thing because you can convert garbage into electricity. Garbage is converted into electricity. So this is very see the strategies to control pollution. Now we were discussing about the types of pollution, and now the conclusion part, that is strategies to control environmental pollution. So after studying about the air, water, soil and industrial waste pollution in this unit, by now you must have started feeling the need of controlling environmental pollution. So let us see the methods. First one, we are going to talk about waste management. Solid waste is not only the waste which you see in your household garbage box. Besides the household discards, there are medical, agricultural, industrial and mining waste also. The improper disposal of the waste is one of the major causes of environmental degradation, and the management of these waste is of utmost importance. Now, collection and disposal. Now we can keep separate waste bins, one for biodegradable and another for non-biodegradable, so that these two can be dumped separately, and as a result of which we can uh, cause the problem of soil pollution. We can pause the problem, or we can say check the problem of soil pollution, right? Therefore, all domestic waste should be properly collected and deposited. Poor management causes health problems leading to epidemics due to contamination of groundwater. It is especially hazardous for those who are in direct contact within the waste, such as the rag pickers and workers which is involved in the waste disposal, as they are the one who handle waste materials mostly without any protective devices such as gloves or waterproof boots and gas masks. So to protect their health also, we have to be concerned, and we have to separate the waste into two. One waste bin is should be kept for dumping the biodegradable and another should be kept for non-biodegradable waste. Now moving on to the last topic of this chapter, that is green chemistry. Now, in the late 20th century, by using fertilizers and pesticides, the amount of food that is produced in the country has been increased. But what has happened? There has been increasing soil pollution, there has been increasing water pollution, and also due to air pollution. So, let us see how we can apply the concept of green chemistry to our day to day life. First one, dry cleaning of clothes. Tetrachloroethane, ethene, that is Cl2 C double bond CCl2, that was earlier used for the dry cleaning purposes. Tetrachloroethene, the compound contaminates the groundwater and is also a suspected carcinogen. The processes using this compound is now being replaced by a process where liquefied carbon dioxide with a suitable detergent is used. Replacement by the halogenated solvent by liquid carbon dioxide has resulted in less harm to the groundwater. So earlier we used chloroethene and that is a pollutant, and now instead of that we are using liquid carbon dioxide, which is not at all a pollutant. Similarly, we can also use H2O2, that is hydrogen peroxide, in bleaching of clothes in the process of laundry, which can also gives us better results and also less polluting. And next one is in the bleaching of paper. Earlier chlorine gas was used and that is a pollutant, and now we are using hydrogen peroxide with suitable catalyst which promotes the bleaching action of hydrogen peroxide. Next one is the further synthesis of chemicals. Ethanol is now commercially prepared by one-step oxidation of ethene in the presence of ionic catalyst in aqueous medium with a yield of 90%. So, similarly, we can say that green chemistry in a nutshell is a cost-effective approach which involves a reduction in material, energy consumption, and waste generation. So, it is helping in preventing, or we can say reducing, the pollution. So with this we are completing the theory of this chapter. Now let us quickly check some important questions related to this particular chapter. Question number 1. The layer of atmosphere which extends up to 10 km from the sea level is called as troposphere. Troposphere pollutant it can contain dust, water vapor and mist, so it should be all of these. Which one of the following is a secondary pollutant? Secondary pollutant means they have no direct contact with the atmosphere. Carbon monoxide has direct contact, so it is a primary pollutant. Ozone does not have a direct contact, but it convert the other compounds such as NO2. We have seen it is converted into NO3 minus, and this NO3 minus for more pollution. So this is a secondary pollutant. Lead and methane on the other hand, these are primary pollutant. Next question, which of the following pollutant causes irritation in eye? This we have already studied. It is sulfur dioxide. Primary pollutant is CO is a primary pollutant, DDT is also a primary pollutant, and CO2 is also a primary pollutant. So the answer is option number 4. Let us move on to the next question. Which one of the following is a colorless, highly toxic gas which reduces oxygen carrying capacity? So by seeing this particular part, we can answer that it is carbon monoxide. Which one of the following affects chlorophyll? Now we have to study this. Exposure of plants to lower concentration of SO2 over longer periods hampers the production of chlorophyll. So the answer should be option number 1. Next question. Which of the following oxides produces brown or reddish brown haze? It is the oxides of nitrogen, especially NO2. Which one of the following gaseous pollutants is carcinogenic? We have arsenic, which is a carcinogenic substance. Next, photochemical smoke involves ozone, NO and NO2. So the answer is all of these. Select the viable pollutant. Viable means it is living. Smoke is not living, so this cannot be the answer. Mold is living, so this can be an answer. Mist is not living, and fumes is also not living. So the answer is option number 2. Which of the following is not a property of classical smoke? It occurs at low temperature. Yes. Classical smoke occurs at cool temperature. Secondary pollutants plays significant role. That is wrong. So this should be the answer. Photochemical smoke always contains ozone, so the answer should be 2. Depletion of ozone layer cannot cause. It cannot cause damage of DNA. Yes, it can cause damage of DNA. It can cause skin cancer. It can cause cataract, but it does not cause rickets because is due to rickets is due to vitamin deficiency. Which of the following is known as a chemical weed in the troposphere? We know that the ozone in the troposphere is known as bad ozone, and that which is present in the stratosphere is the good ozone. Bad ozone is same as the chemical weed, so O3 is the answer. Depletion of ozone layer can causes increased transpiration, damages paints and fibers. This is also correct. Causes aging of skin. That is also correct. So the answer is option number 4. pH of rainwater is 5.6 because of the presence of H plus ions that is formed by the reaction of water with carbon dioxide. Which of the following is not a cause of acid rain? CH4 is not helping in acid rain, whereas NO2, SO2 and CO2 has its contribution to acid rain. Acid rain causes chlorosis, increasing acidity of the soil, corroding of the bridges. So the answer should be all of these. Interference in the development and maturation of RBC is caused by, as we have already studied, it is lead pollution. Tooth decay is caused by the deficiency of fluorides. Cause of eutrophication is the natural or nutrient enrichment in the water bodies, especially due to nitrates and phosphates. Inorganic kidneys and the central nervous system, so the answer should be option number 4. Which one of the following is the least persistent insecticide? Least persistent is asked, so it should be carbamates. These two are highly persistent. Even this is highly persistent, but this one is least persistent. And this we have studied in the previous chapter, benzene hexachloride, which is also known as gamaxine. Which one of the following is a herbicide? We have studied that the herbicides is sodium arsenite. Now the next question, in the place of tetrachloroethane in ethene in dry cleaning, we can use hydrogen peroxide and also liquid CO2 as well. Sharov won 2005 Nobel Prize for the development of metathesis method, which is a very important method in green chemistry. So with this chapter, and in the next video lecture we will be covering up the chapter haloalkanes and haloarenes. Please do not forget to like any important notifications and be a part of our Telegram app for the PDF of all these lectures and also every updates. So see you again in the next lecture. Till then, goodbye and happy learning.